Hi, physical science students. Today we're going to talk about how to fill out this chart. And basically what we are doing by filling out this chart is to identify the different parts of the atom and the numbers of the different parts of the atom. So how many protons are there? How many neutrons? How many electrons are in an atom? What is its element symbol? What is its name? What is the atomic number? What is the mass number? And how can we get the missing pieces from what we already know? So when we do a chart like this, what we want to do is look at the information that the chart gives us. And the first thing that we want to notice is that we have an atomic number space. Sometimes the number is given, sometimes it isn't. But the atomic number tells us the number of protons, and it tells us the number of electrons every single time. So that's what the definition of atomic number is. It tells us the number of protons in an atom. And because we're talking about neutral atoms, atoms that have the same number of positive charges as negative charges, the number of electrons will be the same as the number of protons. So for this first line right here, we have boron. Boron has an atomic number of 5, therefore it has 5 protons and 5 electrons. Now, you may not know that boron has, or what the element symbol for boron is, so for that, we're going to take a periodic table. Now, on this periodic table, I look around and I notice that, let's see if we can zoom in here, boron is given by the element symbol or the chemical symbol B. So I'm going to fill that in. And the last space I have is the number of neutrons. Now the number of neutrons is given by taking your your mass number minus the atomic number. So I have a mass number of 11 for boron, and I'm going to subtract the atomic number of 5, and that is going to give me 6 for my number of neutrons. And so I'll fill that in, and that's all there is to that one. That's pretty straightforward. Okay, let's move on to the next one. The next line, we are given the element symbol Na, we are given the number of protons, and we're given the number of neutrons. Now remember, if I know the number of protons, I also know the number of electrons. So that's going to be the same thing. And protons and atomic number are the same. So again, I have those 3 columns filled out as 11s, atomic number, protons, and electrons. Now the neutrons are given here as well. Now if I want to know what the mass number is, the mass number equals protons plus neutrons. So in this case, it's going to be 11 plus 12, and that will equal 23. So that's the mass number for my element. Now the last thing I need to know is, what does Na stand for? So again, I'm going to look at my periodic table. And you might have to search around for a little bit at the beginning here, but we'll see that Na is right here, and it stands for sodium. Now, you might say, well, why does sodium get abbreviated with an Na? And it's using a Latin name for sodium in order to make that abbreviation. So the element name and the element symbol don't always match up letter-wise. Okay, let's move on to the next one. The next line, I have an atomic number of 31, so that means that I have 31 protons and 31 electrons. Again, atomic number, protons, and electrons are all the same. I have the number of neutrons, so protons and neutrons will give me my mass number. So that's going to be 31 plus 39, and that is 70. So I can fill in 70 for my mass number. Now I need to know, what element is this? Well, every element has its own unique atomic number. There's only one element that can have an atomic number of 31. So if I look on my chart here, I find the atomic number, and that is Ga, and that stands for gallium. Okay, let's move on. The next question, the only information we're given is the element name. So let's take a look here, and that is tungsten. Tungsten is represented with the letter W. So let's zoom in on tungsten. And tungsten has an atomic number of 74. So let's fill that in. I said the abbreviation was, or the element symbol is W. 74 is the atomic number, which means that that's also the number of protons and the number of electrons. Okay, now we need to know the mass number and the number of neutrons, but I can't figure out either one. I need the mass number to find out neutrons, but I also need neutrons to find out the mass number. So how can I figure this out? And so what we do in this case is we look back at our periodic table, and we will see this other number at the bottom. That is our atomic mass. Now, here's the thing. You'll notice that number says 183.84. A mass number has to be a whole number. So what we do is we take that number and we round it, and that will round up to 184 for our mass number. So 184. Now I can figure out the number of neutrons. So I'm going to take mass number minus atomic number, 184 minus 74, and that's going to be 110 for my number of neutrons. Okay, let's move on to the next one. This one, I only give you the number of electrons. Well, again, if I know the number of electrons, I automatically know the number of protons, and I know the atomic number. Now, I can see the atomic number is 86, so let's see which element that is. That's right here, Rn. And Rn stands for, let's take a look, radon. Okay. Now we're in the same situation we were in with tungsten. We don't have a mass number and we don't have the number of neutrons. So I have to again look at what I have on this chart right here. And here it's 222 for the atomic mass. I don't need to round that. It's already rounded. So I'm going to put that in for the mass number, 222. And to find the number of neutrons, I will again subtract 222 minus 86. And that's going to give me 136 for my number of neutrons. All right, 2 more to go. Let's go to carbon. How did I know that was carbon? Because it starts with, or it's abbreviated with a C. So I'm going to fill carbon in right here. Now, I'm given the number of neutrons. How does that help me? Well, at this point, it doesn't. Let's first find out what is the atomic number of carbon. Carbon has an atomic number of 6. So I'm going to fill in the atomic number, I'm going to fill in the number of protons, and I'm going to fill in the number of electrons because they're all the same. Again, to find the mass number, I take protons plus neutrons. 6 plus 8 equals 14. Now, if you've been paying attention to your periodic table, you might look at carbon and go, wait a minute, the atomic mass is 12.0107. If I round that, that rounds to 12. It does not round to 14. What this is showing is one particular kind of carbon atom that has a mass number of 14. It's called an isotope. If you are in a situation like this on a test or on homework, go with the numbers that are given on this grid. Do not correct this number for what you would see on your periodic table. All right, one more. Again, this one's going to be a little bit trickier. And we're given an atomic number and a mass number. So let's find out what the number of protons and electrons are. Atomic number is 1. Therefore, this is 1 and this is 1. Okay, to find the number of neutrons, we take the mass number minus the number of protons, or mass number minus atomic number. It's the same thing. 3 minus 1, that is 2. And if I look on my chart, the atomic number of 1 is hydrogen, abbreviated with an H. That makes sense. And again, if you look closely at hydrogen, you'll see that the atomic mass is 1.00794. If I round that, it rounds to 1. But what we have for a mass number is 3. Again, that's not the same as what you see right here. But again, this is an isotope of hydrogen. Some hydrogen atoms come like that. They come with a mass number of 3. Very rarely does it happen, but it does happen, which then gives you more neutrons than you would normally have. So that is how to fill out an atomic grid, and that's all I've got for you right now.